Hi, in this video we are going to learn how to route a hydrograph using reservoir routing method, or it is also called as level pool routing, or it is also called as modified pulse method. Now we have learned how to route a hydrograph using linear reservoir, so we can also think of this as nonlinear reservoir routing. So in case of nonlinear reservoir, we have relationship between storage and discharge as S is equal to K Q to the power of some exponent N. Okay, so we have the storage discharge relationship, and then we need the continuity equation, which is ds over dt is equal to it minus qt. Okay, and if we want, we can again just draw a simple reservoir here. We have input and then we have output. Okay, and then this is our storage, and this storage has a nonlinear relationship with the discharge. Okay, so let's derive an expression on how we will solve this routing problem using nonlinear reservoir. So we'll start with our continuity equation, which is ds over dt is equal to it minus qt. We have done this now quite a few times, so now we have sj minus 1 over delta t is equal to ij plus ij minus 1 over 2 minus qj plus qj minus 1 over 2. As usual, all the i's are known, so this will be our input hydrograph here. That's our I, and we are interested in finding how it will look after routing it through a reservoir. So this is what we are interested in. Okay, so again, initial conditions are known. So in this case, we know S0 and Q0. Until now, we did not care much about S0, but in this case, it is necessary. So initial condition means initial storage, and initial discharge is also known. So what I'm going to do now is I'm going to write down the unknown on the left hand side. So this is going to be 2 over delta t. So what I did was I brought this 2 on the left hand side. So the unknown in this case is sj. Okay, and then we also have qj, which is unknown, so we have qj. Okay, and then on the right hand side we have ij plus ij minus 1, and then minus qj minus 1. And then we also know the initial storage, which is going to be plus again 2 over delta t sj minus 1. So if I write this expression, what I have is 2sj over delta t plus qj is equal to ij plus ij minus 1 plus 2sj minus 1 over delta t minus qj minus 1. Okay, so as I said, all the i's are known, so ij is known, ij minus 1 is known, and if we are solving this for q1, then we also know s0 and q0. So for the first time step, we know all these values, which means that you end up with an expression where you have this part known and this part is unknown, 2sj over delta t plus qj. Okay, so we have two variables that are unknown. Sj is unknown, qj is unknown. So how do we solve this problem? And that is where the relationship between storage and discharge comes into picture. So for example, if we know this relationship, let's say we know k, we know n, what we can then do is we can just assume some values of q. So I'm just going to create this as an example. So I have q and I can just say q1, q2, q3, q4. I can just assume some values for that, and once I assume these values, we will know what k is and what n is. So n and k are given, and then we have s, s1, s2, s3, s4, and so on. Okay, once you know what q is, once you know what s is, then you can create another column which will be 2s over delta t plus q, and then you will have some values here. So I'm just going to call this as y1, y2, y3, y4. What this gives us is, for example, once I find a value for this, I can then come to this table and look at this column, and if my value of 2sj over delta t plus qj is, let's say it's same as y2, then I know that my q is this. And once I know q, then I get this part, right? And that is what we need. And this relationship between q and 2s over delta t plus q is called storage outflow function. Okay, so what this storage outflow function does is, by solving the right hand side of this expression, we get a value for this, and then by using the storage outflow function, this function, I can find what q is. Okay, so this is how we get q values, by using this expression, which is our expression for the modified pulse method. Okay, and then in conjunction with the storage outflow function, we can get values for q's. Okay, so this is how this works. Now in this case, we had this relationship. In practice, you may just have values for q and s, and then you can still develop this column. Now in this example, I said that after I solve this side, I got a value of y2, but in some cases, or in most cases, it's not going to be the exact value you have here. It may be somewhere between y1 and y2, and then what you do is you interpolate and find the value corresponding to that, and which will be between q1 and q2. So that will be linear interpolation. Or if you have the data, you can also plot and create a relationship between Q and 2S over delta T plus Q. Okay, and again, depending on whatever value you get here, you come back and look at that value on this and then get the Q value and so on. So there are multiple ways of using the storage outflow function. You can either use an expression or you can use a table, and we will see how to do that when we do a numerical example next time. So since this method is little bit complicated compared to the linear reservoir and Muskingum method, we can also write down the steps in level pool routing. So the first step is always develop the storage outflow function, and this could be a table or a curve. So this will be 2s over delta t plus q versus q. Okay, and then our inflow hydrograph is given, and then initial condition S naught and Q naught, initial conditions given, and then we solve for S1, which will be 2S1 over delta T plus Q1 is equal to I1 plus I0 plus 2S naught over delta T minus Q naught. Okay, so this is what we have, and then you have this, and once you have this, you go to this and get Q1. Okay, get Q1. Once you have Q1, then you can also get S1. So after you get Q1, then find S1 from this expression here. Okay, and once you have S1, then this S0 and Q0 for the next time step, you will use Q1 S1 and solve for S2. So continue this process. Okay, so I hope you understand the process. If not, you will see how it works when we do the numerical example in the next video. Okay, so this is it for the reservoir routing method, which is also called as level pool routing or modified pulse method, in which we have non-linear relationship between storage and discharge. Okay, so this is it for this. I will see you next time. Thank you.